We're now going to get insight on how artificial intelligence and artificial brain works. And I would like to welcome someone who's been involved with IBM Watson, which is the leading artificial intelligence project that most of you know. So please join me to welcome Satya Nitta, who is Program Director, Education and Cognitive Science Department at IBM Research. Thank you.
Everybody, close your eyes, ascend, go up. Everybody, close your eyes, ascend, go up.
Good afternoon. It's actually very difficult to follow the last speech, but I'll try my best, and I'll talk a little bit about something we're very passionate about at IBM, which is AI. And intelligent tutoring systems, in many ways, the study of ITS systems is really the study of AI itself as a field, because in the early days, the founders of AI, when they were asked, people like Simon and Newell and even Marvin Minsky, Alan Turing, what AI would be good for. Why would a computer have to be intelligent? One of the things they always used to say is, we'd like a computer to teach other people, right? So it's been something that the visionaries and the founders of this field have always held in the highest esteem as an application area, and it's actually taken a very long time to get here. Later on in this talk, I have a brief slide on the history of intelligent tutoring systems, but I thought I'd get it out there that this is one of the holy grail applications of AI, and it's my pleasure to work on this field and to share some of our insights with all of you today. So I'll start off by showing this quote by Dennett, and I'll actually let you read this for 30 seconds before I weigh in on some remarks. So what Daniel's really saying here is that there is no such thing as biological intelligence in computers, right? And I find this quote in particular very compelling, because there's this narrative out there about AI as a field and as a technology that will take over the world at some point, 2049, et cetera, if you believe some of the singularity folks. But what Daniel's saying is actually absolutely right. AI is actually very limited, and there is no attempt to create biological intelligence, primarily because we actually have very little idea of how biological intelligence actually works or actually arises in people. And to think that in a short 50, 70-year history of computing, we could actually get to what nature took 3.5 billion years to do, is highly, highly egotistical of us as a species. But what I'm interested in is really not how limited AI is, but what one can do within those limitations. And it turns out you can do a lot within the limitations if we understand where the boundaries are and what AI could do and what we could be very good at doing with it. So I'll talk a little bit in particular about 3 branches of AI that we're really interested in. The first, of course, is what IBM Watson was very good at, which is natural language processing, reasoning, and there was also some level of speech synthesis, and of course, information retrieval was at the heart of what Watson did. But one of the sub-branches of what was in Watson, but that's now taken off and become a huge field of study on its own, is this whole area of knowledge representation, and the notion that in order for any intelligent system to do what it does, we have to find out ways to codify human knowledge into ways that computers can understand, and then one can actually reason on top of that knowledge. And finally, the thing that's extremely hot today, and wherever you go, even in this conference and several conversations, the whole notion of chatbots and conversational systems has come up quite a bit. And it's actually at the intersection of all these that we can do some really, really interesting things, and in particular, we could actually build some very interesting intelligent tutoring systems. Underpinning this, of course, is the whole field of machine learning, which is sprinkled throughout all these areas. So I didn't call that out separately. But I want to now show you what's actually happening in the field of intelligent tutoring systems. What are we doing? Where we think the limits are, etc. And before I do that, it might be helpful to start with a bit of a definition that we can all agree is what an intelligent tutor is. I'll also contrast this with adaptive learning. But this is actually from Wikipedia, and it's very accurate. An intelligent tutoring system is really a computer system that works autonomously with people, and without any human intervention, it teaches people things that they want to learn. And so again, I want to emphasize the notion that it's autonomous. So it's not actually getting any prompts or hints, or there is no wizard of Oz behind the curtain. The computer is independently trying to diagnose where a person is, what they're trying to do, what they're struggling with, who they're like as a learner, and it's trying to then intervene and give them the best possible advice. It could do so in a variety of ways. Dialogues or a conversational chatbot is just one modality or one mechanism, but it doesn't have to be the only mechanism. Even a system that diagnoses how you're solving a problem in physics and starts giving you prompts and hints without any real conversation between the learner and the system is an intelligent tutoring system. Right? So it's had an extremely rich history, and I want to acknowledge a tremendous amount of work, in particular the work that happened in the 1980s at CMU. John Anderson started the work. There were a number of initiatives before the CMU work, actually in the 50s, 60s also, that led up to the formal work in ACTAR and intelligent tutoring. It was carried on by a number of people, luminaries. Marvin Minsky spent some time in it. People like Ryan Baker and Ken Kettinger at CMU are spending a huge amount of time working in this area. There's Kurt Van Lin, who's also spending time. So there's a very, very rich history. And the history in some ways mirrors what happened to AI. So in the winter of AI, the field essentially receded. There was still work going on in 2 or 3 research labs, but it didn't catch the wider popular imagination. But with the revival of AI, in particular around 2006, people started looking at it again, and we came along, several years later, and we got very interested in it when we started this initiative on education. And so one of the first things we did was to go back and read all this history, and we contrasted the amazing amount of work here to the work that's going on in the adaptive learning community, and we were actually quite surprised that there wasn't much more of an attempt to do the more ambitious kinds of things that ITS systems do. And we view adaptive learning as a necessary first step. In particular, we think recommender systems are very important. But we don't think they're sufficient, and we do think we need to go beyond them to intelligent tutoring systems, which are autonomously working with the learner to get to this whole notion of personalized learning. So let's spend a little bit of time talking about what an intelligent tutoring system looks like and how it works, and what some major components are. This is a very highly simplified flow graph. There's again lots of very detailed flow graphs out there on the web. You could go to Google Scholar to get some very nice papers. I don't think there's a great review paper written on this yet. But suffice to say, some of the most important components of a tutoring system are that the system determines at some point what kinds of problems or questions to pose to the user. And the computer, when it poses the question, already has a stored knowledge of how to approach a problem. And that's pre-coded in some ways, and in other ways it's actually automatically generated. And whether it's pre-coded or auto-generated is basically a huge decision, and a lot of work goes into figuring out whether certain domains can lend themselves to automatically generating a solution. But importantly, when the human provides a solution, and the response, again, one thing I want to stress here is that the response that humans provide in ITS systems is much more complex than a multiple choice selection. They're typically trying to solve a problem, they're trying to create a flow graph, or they're trying to type in a response in free form using human language, English in many cases. So it's very complex responses that people provide. And so the whole goal of the system is then to compare the stored approach to the problem and the human approach to the problem and figure out whether the person's on track or not. And this is where the heart of the tutoring system basically comes in. It's this comparison, the analysis of the human response, a diagnosis of things like misconceptions, gaps, and then based on that, it's going to determine what it should do next. And so between these two modules, the comparison and the next best action module is where the heart of the tutoring system lies. And the system then comes in and says, well, okay, you kind of got that right, let's move on, let's update your mastery model. I'll note that as, you know that particular node or that particular concept. Or if you didn't, at varying levels, it'll determine what to do. It'll basically say, maybe I'll give you a hint, maybe I'll give you a prompt, or maybe you should go watch a video, maybe you should do this exercise. And it will make some decisions completely autonomously. And it will then go back and ask the person to respond again to the same question or to an associated question. And ultimately, the goal of the entire system is to help you master a particular concept before you move on. And in that way, there is something in common with adaptive learning systems. But the complexity of determining what a student knows or doesn't know, what it should do, how it should approach the problem, the complexity of generating solutions and doing this in a domain-independent fashion is entirely a different beast altogether. And this is where it contrasts and differs entirely from adaptive learning. Under the covers, there's a bunch of things going on. There's a huge amount of NLP, sketch understanding, which is this sub-branch of AI where people draw figures and the system attempts to understand it. There's things like rule-based conversations. There's stochastic conversational systems and machine learning-based learner models that are essentially trying to figure out what you know and what you don't know with a degree of certainty. So all these things are going on, but the net result is you basically have a system that has some level of stored expertise, and it's attempting to convey this expertise to the human, and in that way work with them and make them a lot better at that particular subject. So we are, in fact, embarking on a personalized tutoring project at IBM. I think of the major companies, we are probably the most ambitious or aspirational effort, which doesn't mean to say that we're actually the most advanced. We just have a lot of aspiration and ambition, and we realize that this is very challenging. So we're doing a whole bunch of things. Our tutoring system is a dialogue-based tutor. In particular, there's been a lot of work here by Kurt Van Lin and the auto tutor community. So we are building on top of all this amazing work in academia. We have a bunch of things like learner models. We have concepts that we cluster, that we automatically extract from a glossary of text in any particular domain. And about 90% of the extraction is automatic, and then there's some 10% work to verify whether what we extracted using machine learning is actually accurate or not. Then we, of course, have our deep QA, which is question answering, which is what Watson won Jeopardy with. And we also have a new module that we're building. We're taking on a very hard problem in NLP, which is called short answer analysis. So this is a student provides an answer, and the computer is automatically trying to figure out if what they got is right or not. And I want to talk about that for one quick second. So the contrast between a human-provided answer and a multiple-choice answer is actually vast. One can argue, and I would personally argue, that you can actually guess your way through various types of multiple-choice answers with a fair degree of accuracy. I've done it a fair bit. I think part of why I'm here is I probably was more lucky than others in guessing some of these answers. But it doesn't actually show any real learning. Learning is different from identifying a concept or retrieving some stored fact from it. Learning is much more complex. But the notion of providing a human-generated response is an entirely different thing. So language is really fundamental to who we are as people, and we show a huge amount of understanding or lack thereof through language. And so the big kind of holy grail type task here is to take human language and get a computer to understand whether you demonstrated sufficient mastery of a particular idea or not. So it's a module that we're spending a lot of time and resources in, and it is especially challenging. And before I go on to show you some demos, I want to talk about an experiment that Ashok Goel of Georgia Tech carried out a few months ago, about a year and a half ago. And what he did was he had this computer science class that he was teaching as a brick and mortar class, but he also had an online version of it with a few hundred students taking it online. And he had a bunch of teaching assistants, and the teaching assistants were doing all kinds of things like answering questions, etc. And one of the TAs was Watson, and he called it Jill Watson. And what he did was he didn't actually tell anybody, including his human TAs, that this was a robot. And so at the end of the semester, the feedbacks came, the evaluation came, and Jill Watson had the most successful evaluations, and it was not much of a surprise because some of the comments were, this robot would, this TA would answer questions even at 2 in the morning immediately. I posted a question, it would answer immediately. And so none of the students or the TAs caught on to the fact that it was actually a bot doing the question answering. So it was only doing one thing, which was answering questions. So if you go back here, it was doing the thing on the far right. But even that, at least as an experiment, was illustrative of the fact that a system that's giving you information when you need it in the way that you want it is likely to be highly effective and highly engaging. So we basically built on top of that. I mean, this was going on in parallel to the effort that we had going on at IBM, and we had many discussions with Ashok, but we didn't actually participate in his experiment. We just provided access to the Watson system. But what we did do over the last couple of years is we formed a couple of major partnerships. Now, we're a technology company. We don't have access to content. We don't have access to the channel. And we certainly don't have access to all the expertise and the cognitive sciences that go with education. So we partnered with Pearson and Sesame Workshop to build intelligent tutoring systems. And with Pearson, we're building an ITS system with Watson that will be embedded within their digital courseware in a variety of higher education disciplines. It's early days. It'll take a couple of years for us to get our first real product out there. But I can show you some very quick snippets of what we're doing. If we can play this video, bottom left. Thank you. Right. So again, please excuse the UI. It's a bunch of researchers from my team essentially pretending to be UI experts. But you will see the kind of interaction that's happening. So the system, which is Watson presents a question, the person provides a response, it's partially correct. Watson comes back and says, there's more to this answer. It's giving them a hint. The person says, I don't know, and in slang, and Watson's basically scaffolding the entire learning process. And it's saying, well, this is a hint, and this is actually what's going on. You got this part right. There's more to the question, etc. Right? Again, I apologize. It's going through rapidly. In the interest of time, I'd be happy to talk about this afterwards. But basically, there's also things like support for question asking and question generation within the system. So as you're typing a question, Watson will help you with some frequently asked questions. If your question is there, you can type it. It will retrieve a high-quality answer. If the question isn't there, then Watson will basically, if it doesn't actually know it, it will look into the textbook, and it will pick the most accurate answers it thinks, answer the question that you have, and it will come back and say, did I actually help you? And it will ask you to disambiguate, right? It'll also ask you feedback. This is a way for us to train the system. Tell me what you didn't like about something, and then one of the things it continues doing is it continues persisting with the original question. And when a student asks a question that Watson doesn't actually have any idea about, it finds the closest match, and it says, okay, which of these is the question that you have? And it retrieves the right answers. So it's basically this notion of a conversational back and forth that's happening between the system and Watson. And one of the things we don't show here, but we are absolutely doing, is this is just a chat experience. We're much more interested in a bunch of other things like grouping concepts, drawing things. Watson can show you, for instance, a picture of the ear, the outer ear, and the inner ear, and it'll say, can you label all the parts of an outer ear, and can you draw a circle around it? And if you draw it and you get it wrong, Watson will say, well, maybe you missed out some part of it. You circle the ear canal, which isn't a part of the outer ear, it's a part of the middle ear. So the experience will go beyond this text back and forth to much more of a multimodal dialogue, as we call it, right? This is kind of an example of dialogue-based tutoring, and there are many challenges that are buried in here, which I glossed over in the two-minute video. But in particular, this notion of a conversational system keeping state, which is understanding where you are, what you're talking about, through a long dialogue. Sometimes these dialogue sequences can go on for a couple hundred exchanges between the system and the human, and it has to maintain state at all times. And it also has to determine engagement. Are you getting bored? Are you getting tired? Are your responses taking too long? And there have to be some models at the back end that have to come in and say, okay, if you're engaged, if you're not engaged, let's do something else. Then it also needs very high accuracy in classifying student answers and student intent. So somebody answers, we really worry a lot about, if a student answers a question, we worry, of course, about getting a student answer that's right classified as wrong, but we also worry about giving them positive feedback when they actually got the answer wrong. So there's all these combinations of the student gets it right, the system thinks you're wrong, the student gets it wrong, the system thinks you're right, and variations in between that we have to deal with and figure out how to give appropriate feedback, and the tutor has to have a personality in the process. The dialogue between the system and the student should just be used as an interface. It really can't be much more than that. But it also has to be domain agnostic. So we showed you an example in psychology, but it has to stretch across multiple domains. And then across many domains, we have to figure out whether students are getting the answer right or not. And we have to represent student answers and the tutor logic in a fashion that it's very easy to bridge across these domains. So these are some high-level challenges. You have 1 minute. 1 minute? Okay, thank you. These are some high-level challenges, and it remains to be seen how successful we will be in building this broadly universal tutoring system. So finally, we're also doing tutoring in early childhood, in particular with Sesame Workshop. The idea here is we're taking some of the underlying components and opening them up over the next year or so to a bunch of people who want to simply do things like learner profiles for personalization, or they want to take the concept graphs that we build, or they want to take the automatic assessments that we build. So people can use the tutoring components and build personalized learning applications without actually building a full-scale tutor, or they could build a full-scale tutor. And in the interest of time, I will skip over this next video and end with this one slide of Marvin Minsky, where he basically says a model of human intelligence is that all the interactions are built up from simple parts called agents, and these simple parts are actually by themselves not intelligent, but when they actually come together, it gives rise to this larger notion of human intelligence. In some ways, cognitive systems are very similar. All these applications and all these algorithms are relatively dumb, but if you put them together, you can create something much more compelling and much more useful. So with that, I'll end my talk. Thank you.